Today's topic is debye huckel theory of strong electrolytes. This is very important topic for descriptive exams and objective exams also. So I am requesting you please carefully watch this video and prepare your notes by following this video. This theory explains the variation of equivalent conductance of strong electrolytes with dilution. The fundamental is that the increase in conductance of strong electrolyte with dilution is because of decreasing in electrostatic attraction between the oppositely charged ions. Here we have to discuss the significance of debye theory. As we know that strong electrolytes means the substances which can ionize completely at any concentration. But in actual practice, the conductance of strong electrolytes is observed that the increasing as they diluted. So here, although the number of ions is constant at any concentration or any dilution for strong electrolytes, because of minimizing of electrostatic attractions in between the oppositely charged ions is the reason for increasing in equivalent conductance of strong electrolytes as we dilute the electrolytic solution. This is the significance of debye theory. Briefly, I am repeating again. We know that strong electrolytes undergo complete ionization at any concentration. Although the number of ions of strong electrolyte is constant at any concentration or any dilution, there is an observation that increase in the conductance. This theory explains the reasons for increasing the conductance of strong electrolytes on dilution. This theory explains about interionic attractions. Here, let us see interionic effects. The electrical attractions among the oppositely charged ions which affects the speed of ion in the electric field is called interionic effect. I am repeating again. The electrical attractions between the oppositely charged ions which affects the speed of an ion in the electric field is called as interionic effect. These are also called as interionic attractions. There are two such effects, that is relaxation effect or asymmetry effect, and the another one is electrophoretic effect. This visualization gives some information regarding relaxation effect or asymmetry effect. At lower dilutions, that means at higher concentration, there would be a symmetry in the electrolytic solution. That may be either cation surrounded by anions or anion surrounded by cations. At high concentrations, we can observe such type of symmetry. When the solution of strong electrolyte is diluted, the symmetry get disturbed and the mobility of ion will be increased. This leads to increasing in equivalent conductance at dilutions. This is another effect, that is electrophoretic effect. Here let us see electrophoretic effect also visualized like this. Here the positive ion overcomes the attractions of negative ion. This is possible at dilute solutions only. And the same way, when the solution is in dilution, the negative ions also overcome the attractions of positive ions. This is debye-huckel onsager equation. Debye and Huckel derived a mathematical expression for the variation of equivalent conductance with concentration. This equation was further improved by ONSAGER and is known as debye-huckel-onsager equation. Note down this equation carefully. Here, delta C is equivalent conductance at concentration C, and delta infinity represent equivalent conductance at infinite dilution. D is equal to dielectric constant of medium, and eta is equal to coefficient of viscosity. T is equal to temperature. C is equal to concentration. Here let us see, being dielectric constant and coefficient of viscosity are constant for given electrolytic solution, the above equation can be simplified as follows. Here A and B are constants for a particular solvent. We can make the following interpretations from debye-huckel-onsager equation. Let us see, on y-axis equivalent conductance is taken and on x-axis concentration is taken. So if we can observe this graph carefully, as concentration increases, equivalent conductance decreases. Okay, observe this carefully. Being the value of concentration increases from left to right and equivalent conductance also increases from left to right. If you observe this plot from right to left, as concentration decreases, equivalent conductance increases. Thank you. Happy learning.